Good afternoon, everybody. Hope you've managed to join us successfully. This is the first of a series of building safety webinars hosted today by the IMechE. My name is David Smith. I'm the co-chair of the Institution of Mechanical Engineers Construction and Building Services Divisional Board. I'm here just to provide a short introduction to the 12 building safety webinars that have been developed in collaboration between ourselves at the IMechE in the CBSD board, the Institution of Civil Engineers, the Institution of Structural Engineers, the Institution of Fire Engineers, CIBSE, the Chartered Institution of Building Service Engineers, the Engineering Council, and last but not least, the Building Safety Alliance. These webinars have been developed really to respond and as a consequence of the Grenfell tragedy and other events, and so that we all learn from what has happened, what's been developed, and improve our understanding of the forward-going requirements and look to prevent similar issues occurring in the future. On a personal note, even as the chair, I've had very little to do with this review. However, I'm ably supported by a host of fellow board members who have been heavily involved. And these predominantly include the presenter today, Dr. Brian Cox, Conor Logan of Colt International, Benjamin Ralph of Foster and Partners, and our previous chair, Frank Mills. There are 12 webinars, and these will be coordinated, and the details and the link of these provided here on the IMechE website. They will also be on the details will also be on the website of the presenting of the person presenting the webinar of their institution. So not all of them, as you can gather from that, are being presented by IMechE. Each webinar is a standalone webinar. So whilst there are 12 webinars, they don't have to come in order, and they can be treated in isolation. Today, the first webinar will be presented by Dr. Brian Cox, who will introduce the key drivers for change and contextualise the series as a whole. I'm not going to talk any further about that because that will steal Brian's thunder. The following webinar will be about smoke control, and this will be presented by Conor Logan of Colt International. This in the series of webinars you'll see is identified as webinar number 5 and should take place later in May. The details of this webinar and the other webinars in the series, i.e. the 12, will be visible on the IMechE website, and you'll be able to get the details of when they take place just by logging on and having a look. So really, before I wrap up and hand over to Brian, I'd just like to say there's a lot of work that has gone into this by Brian, fellow board members, and other people from the other institutions to make this happen and to bring this to you today and going forward. The IMechE Construction and Building Services Divisional Board is a fairly small divisional board within the IMechE, and if this subject matter is of interest to you, we do a whole host of things, and we would be welcome hearing from you if you're able to add value and contribute to the subject matter. Please, if this is of interest, please make contact through the link on the IMechE website. I'm now going to pass you across to Brian to start the first webinar and the introduction. And thank you for your time. I will be back at the end of the webinar to moderate the questions and to present them to Brian. Hope that's okay. Many thanks.
Okay, thank you very much, David. And good afternoon, everybody. So welcome to this webinar. As David said in his introduction, this is the first of a series. And just a quick disclaimer, mainly because much of this safety information and regulation is still developing, and even as we speak, we know that some things will change. So hopefully I'm as up to date as it's possible to be. So the idea of this series of webinars is to help with something called the safety case report preparation. This is a new requirement in this area of industry, and based on the idea of having a safety case process at work in helping to protect safety in our high-rise buildings in particular. So as David said, this series is based on the work of a working group on engineering set up by the Competency Steering Group and established to support implementations of the recommendations in the Building a Safety Future report, which some people call the Hackett report. And that particular recommendation was that the competence of almost all the people involved in this industry should be improved. This working group, known as WG1, was led by the Engineering Council and is a collaborative project between professional engineering institutions and other partners. So we hope this will help those involved in the maintenance of high-level safety in high-risk residential buildings. And these webinars should provide us introduction to the topics, and hopefully we'll signpost people to further training and knowledge bases that they can get to get a higher level of knowledge and possibly formal qualifications. So this is a sort of story of where we've got to. So you'll remember, I'm sure very well, that in 2017 the Grenfell Tower tragedy occurred. There were, of course, other fires before that and have been other fires since, and we have to continue learning. But the Grenfell Tower fire really focused our attention very well. And following that, there was an inquiry still going on, and many very excellent reports given to the inquiry. But I would particularly like to mention Dr. Barbara Lane's expert report, which is a very useful document to read and study, in that it gives the history of the building, in particular this building, Grenfell Tower, which was built originally around 1974. And as you will have seen from the many, many pictures, the structure still stands there proudly and is not in bad shape really, but it was refurbished in 2015-16, and that was where really probably the problems that we know today started. A second review was asked to be done by Dr. Judith Hackett and her team, and that was called Building a Safer Future. And the recommendations in that report were broadly accepted by the government and have led to the Building Safety Act, which received royal assent in 2022. And as far as our subjects today are concerned, the three very important things came out of that. The first is the setting up of the Building Safety Regulator, which comes broadly under the umbrella of HSE. The idea of the duty holder for a high-rise residential building called the principal accountable person. And the third one, last but not least, if you like, is recognition of residents as important stakeholders in the safety in their buildings through the residents' voice. So if you're a principal accountable person for an occupied high-rise residential building, you will be required to produce a safety case report. We'll try to explain that today. So these new regulations have brought in really a new context for safety in high-rise residential buildings, and particularly the prioritisation of building safety through all the phases of design, build and occupancy, a much better and simpler regulatory framework, a golden thread of information, strengthened construction products regulations, stronger regulatory oversight, and widespread adoption of digital data systems to create a permanent live record of a building's design, construction and maintenance. I thought it's useful to just pull out the key parts of the Building Safety Act which really relate to what we're talking about today. There are many other topics covered in the Building Safety Act, but Part 4 is the one which really applies to what we're talking about. So the Act refers to higher risk buildings, but in paragraph 65, it defines what that means. And it means a building that's at least 18 meters in height, has at least 7 stories, and contains at least 2 residential units. The safety case report is a report which the principal accountable person will have to prepare and submit to the building regulator in accordance with sections 83 and 84. 83 talks about the assessment of building safety risks, and section 84 talks about the management of the risks. And building safety risks under the Building Safety Act are very specifically defined as the spread of fire and structural failure. There may well be other risks for the building, but they're not covered by this particular act. So when we put in a building safety case report, we need to be particularly talking about those two things. Section 83, there you are, is the accountable person must carry out an assessment of the building safety risks, and 84, they must manage those risks. And just at the bottom I put there, the Building Safety Act does not absolve anybody from any of the normal safety responsibilities. So it's not just one act that you have to think about, you have to think about all your other responsibilities. Building in scope, so paragraph 65 said what a high-risk building is, and the total number of buildings which comply with that in the last report which I have, which is published in March 2021, said there were 12,500 buildings in total. 6,500 of those are private sector buildings and 6,000 social sector buildings. So there's a lot of buildings, and clearly the majority of those buildings are going to be always existing buildings, because new buildings are coming on stream at a relatively smaller rate. So here's a typical in-scope residential building timeline, just to try and show what's going on. So we imagine a new build or change of use from a commercial building to a residential building may take 2 to 3 years. And then perhaps every 10 years or so, or maybe longer, there'll probably be some kind of major refurbishment. But the overall occupation of these kind of buildings is typically around 40 years. And below that stream, we have the 3 gateways which were introduced following the Hackett report. The Gateway 1 planning is now in action, and that is a gateway which you have to pass through to get your planning approved. Gateway 2 is a gateway you have to pass through to allow construction to begin. Gateway 3 is a gateway you have to pass through to allow occupation to begin. And during those 3 stages, we have various mandatory roles. So clearly at the beginning of Gateway 1, we have a client. And then as we go through, we have a principal designer and principal contractor. When we get to Gateway 3, we will then have occupation, and then we have a principal accountable person. And that person or their successors or their organization must exist right the way through the life of the building. When we have a major refurbishment, we probably may have a principal designer and principal contractor again, but if the residents remain in residence during the refurbishment work, then the principal accountable person is going to have to continue his job through that. And the safety case really starts from the beginning of the building. In some ways, you could say it starts in the initial detailed design. So I've shown that somewhere through the construction phase. So just to reiterate these 2 points, the golden thread, the idea is that the information, the critical information about a building should be stored safely somewhere so that it can be accessed and passed on to further owners through the years. So in 40 years' time, it's still possible to find out details of how the building was built and designed and maintained. Those of you who are responsible for old buildings will know that sometimes it's really quite difficult to find this kind of information about the beginning of your buildings. So we're hoping that in the future, buildings will carry with them this kind of record of their life cycle. The transition stages, these gateways came in. Gateway 1 came into force on August 1st of 2021, so that's in place. And it ensures that fire safety is a consideration at the design stage, and the developer must submit a fire statement in order to get planning permission, and the health and safety executive is involved in whether or not that planning permission is allowed. Gateway 2 and 3 are expected to come into force in October 2023. So expected timeline for assessment of in-scope buildings is likely to take a period of 5 years to complete. The building safety regulator plans to call in new buildings within the first 6 months of occupation. HSC will start calling buildings in April 24, that's next year, and they'll be called in groups or tranches for assessment. This is what we expect to happen. Basically, the buildings were called in according to their assessed hazard factors. So we've got the height of the building and the number of dwellings. So down the left-hand side, you have the different heights of buildings. So if we take the first height, that's 50 plus meters, and go across, we see all of those buildings will come into hazard tranche 1, except for buildings which are only from 2 to 10 floors, or 2 to 10 dwellings, and that will be in the last tranche, which is 5. And then as you go through, so for example, we take a building with 49 to 53 dwellings, which is a height of 30 to 49 meters, that will come in tranche 3. But if the number of dwellings goes up to 54 to 73, that would then fit into tranche 2. So the distinction between the safety case and the safety case report. The safety case is really the whole of the safety information and supporting evidence and the activities which go on to make the building safe. The safety case report is a document that goes to the regulator to make the claim for the argument of the resident safety and says, we believe this building to be safe because. And it summarizes the key components of the safety case with only references to the supporting documentation. So it's not containing all the different reports and detailed summaries of everything that's going on. It is a report which the regulator can read and come to a conclusion of whether it's justifiable to allow this building to go ahead. So I thought it's useful to give a brief history of safety cases. Very early on was the nuclear industry, and there was a big release of radiation at Windscale nuclear reactor in Cumbria in 1957. That followed by the Nuclear Installations Act 1964 introduced a licensing regime which includes the necessary of having safety cases during all phases of operation. In 1974, royal assent was given to the Health and Safety at Work Act, which introduced really the idea of the duty holder, somebody who was personally responsible for what was going on. And then in the offshore oil and gas industry, safety cases were introduced really following Lord Cullen's report into the Piper Alpha oil rig explosion in 1988, and the actual regulation was introduced in 1992, and I think reviewed in 2005. That requires safety cases to be submitted to the Health and Safety Executive. The chemical industry, the petrochemical industry, control of industrial major accident hazards, CIMA regulations were introduced in 1994. They were introduced following accidents at Flixborough and also at Sarajevo in Italy. They were later replaced by COMAR. And key amongst requirements is the production of a safety report, which demonstrates adequate consideration of dangerous substances and so on. The railways introduced the Railway Safety Case Regulations in 1994, and on the side of air, safety cases were formally adopted as a military platform requirement in 2002. For civil aviation, CAP 760 introduced safety cases in 2010. So now we have in the building industry, the Building Safety Act of 2022. There's a useful paper to read by Mr. Inge, which I put a signpost to there. I thought it'd be useful also to mention the Nimrod review. The Nimrod review was a review of a crash of a RAF Nimrod plane in Afghanistan 2006. And this is a useful thing to be aware of because there was actually a safety case prepared for this aircraft type, but it failed to highlight the problems. And it's really a cautionary tale of not getting into a tick box mentality with safety cases. The safety case needs to be a live document, a live situation, and the safety case report really, if you like, is a summary of the safety case. You could almost call it a kind of audit of the safety case. I put at the bottom there a reference to HSE's support documentation and help. These are very useful files to consult for really detailed information of what is expected of you. So safety case report process we're suggesting is to help you get your safety case report properly prepared. It's a series of process steps, and we imagine that these might quite well be carried out as workshops, possibly with facilitators. Obviously, each organisation is different and will want to develop their own process over time. But this is the suggested process to form a starting point. So these are the process steps we suggest. Number one is information gathering in the golden thread, hazard identification. Number two, number three is prevention and mitigation analysis, root cause analysis, risk analysis. Number six, safety management system. And number seven, finally, preparing a safety case report. So information gathering in the golden thread is a really critical thing to do properly. And as I mentioned earlier, for older buildings, it's sometimes not so straightforward to get all this information together. So we've divided it into two parts: key building information and inspection and maintenance reports. At the same time as gathering and collecting all this information, it should be digitally recorded in the golden thread. And I put below there a couple of references really to what that means. We will later on have a webinar on this individual topic, as we will in many of the other topics. So key building information is now covered by a specific regulation, which is a supporting regulation for the Building Safety Act. It's called the Higher Risk Buildings Key Building Information Regulation, and there's the link to it. And it's supported also with an explanatory memorandum, which explains in detail what goes into that. Inspection and maintenance reports, that should include all the things like fire risk assessments, building condition and structural surveys, and other regular reports which may affect the building's safety risks. So you should also look at process step number 6, which is safety management systems. It may also be useful to consider what goes on in the fire safety regulations, which cover the duties of a responsible person, particularly in relation to floor and building plans, design materials for external walls, lifts, firefighting equipment, fire doors, sirens, etc. There's a link to that. So there's a list of some of the other webinars that are going to go in this series. Hazard identification is the next stage in our suggested process. And the definition of hazard is a potential source of harm. Now, interestingly, the Building Safety Act doesn't use the word hazard at all, but it identifies spread of fire and structural failure as major building safety risks to be considered. And other individual buildings may have other risks to consider, but building managers will have to decide how to deal with this, because the safety case report should only deal with spread of fire and structural failure. So here's some specific guidance, which is extracted from the HSE Safety Case Principles guidance. There again, it underlines that fire spread and structural failure are the requirements of this particular legal requirement. Other risks for people may be included in the new regime in the future. But don't forget, you must continue to comply with the other legislation that applies to your building. And there's a lot of it, and this exists in relation to Legionella, for example, asbestos, gas supply, fire precautions, pest control, and build-up of refuse. And don't forget also the Health and Safety at Work Act, which covers everything really. So hazard identification starts with knowing what these words mean. So hazard is an activity or state of something with the potential to cause harm. So for example, if you have gas supplies in your building, gas has the potential to cause harm, obviously. An event is a situation where a hazard is out of control. So it's sometimes called a top event. So a hazard in the case of gas, that hazard will be out of control if there's a gas leak. A threat is a factor which causes the hazard to become out of control. So it usually means some part of your system is defective. Risk is the likelihood of an event occurring. The consequences are the result of events, for example, primarily harm or worse to people. An issue is an event already in progress. And a barrier is a control which may be designed to prevent a hazard from getting out of control or to mitigate the consequences of an event. So here's another example. A hazard in a block of flats may be, for example, a fire in an individual flat is regarded as a hazard for the whole building. An event is when that fire can spread, so it's fire spread, to the common areas and other flats. And a threat would be when the compartmentation is breached, allowing the fire to escape. So in this case, compartmentation is an example of a preventative barrier. So prevention and mitigation analysis. So what barriers does this building have to prevent building safety risk occurring and to mitigate the effect of them as they do occur? So many people have found bow tie analysis quite a good way of doing this for a building, but there are other systems, and hazard, which is well used in other industries, is also potentially a good thing to use for new builds with complex systems. This is an example of a bow tie diagram applied to a residential building. So on the left-hand side of the diagram, we have a preventative barriers. So for example, our hazard is a fire in a flat. So our prevention might be a sprinkler system, compartmentation, of course. And then if the fire does escape, we have a building fire. This fire spread is the event taking place. On the right-hand side are our mitigation barriers, which we hope will prevent anybody being hurt, or at least reducing the effect of the injuries if they are. So we have smoke detection, fire alarm systems, smoke ventilation, and then we may have some sort of emergency evacuation plan to help mitigate these consequences. At the bottom, I put the safety management system. This is part of it, is the maintenance of these systems, maintenance of these barriers, and fire risk assessment is getting an inspection carried out, and so on. So these all hang together quite nicely in the bow tie diagram. And if this is prepared using a workshop with various members of the team involved, we found it's a very useful way of understanding how your building works. We must be careful because the failure of one barrier can sometimes cause constant failure of further barriers, particularly in a modern building with integrated systems. And common cause failure is something to be aware of. This can occur when multiple barriers rely on, for example, common energy supplies. So if the energy supply fails, then more than one barrier may go out of use without being clear. Root cause analysis, the next step in our process. Root cause analysis means examining an incident stage by stage down until we find really what was the root cause of this problem. The best way of doing this really is to use actual incidents which may unfortunately have occurred in one of your own buildings, because it becomes very real then. If you're lucky enough not to have had any serious incidents in your buildings, then this HSE report, RR1170, gives a report on how a number of serious instance scenarios, that is, imagined scenarios, went wrong, and what was wrong with them, what needed to be corrected. So they might act as potential scenarios you could use in your own root cause analysis. So here's a couple of famous, well, I say infamous really, examples of things that can go wrong. So the one on the left is very famous, Ronan Point gas explosion. This is a structural failure in a large panel system building. So you can see the whole corner of the building has collapsed. And this is because the subsequent investigation of this showed that this particular method of building, the individual flat's strength was not big enough to put up with a gas explosion. The pressure wave from a gas explosion is quite high, and the building needs to be very substantial to stand up to it. So the inquiry recommended a whole range of improvements to the building structure that could be made to help these buildings survive. And there are still quite a lot of these buildings around. So if you have them in your portfolio, you need to be well aware of the requirements of these buildings. On the right-hand side was sadly the Lakanal House fire, which preceded the Grenfell Tower fire. And there you can see quite clearly the spread of fire. So this fire started one of these flats and then spread to the other ones. So that was a warning sign which really didn't get enough notice. So unfortunately, we then had the Grenfell Tower event. So risk analysis is working out how likely it is that things that could go wrong, or how likely it is that the mitigation barriers will do their job and prevent anything too serious happening if there is an event. And the presentation of risk analysis is usually done in some form of chart. And the idea of the chart is to show that all reasonable steps have been taken to mitigate your risks. So here's a chart showing how quite commonly risk assessments are carried out by various teams. This is Haringey Council's risk assessment example. This is on the internet if you want to look at it in more detail. But this is the hazard they were looking at, was the technical failure of the national electricity network and what that would do. So total blackout for up to 3 to 5 days could happen. We've seen that recently in all sorts of cases, where there's been flooding or lines have come down and so on. And they've put that as a high risk, a very high risk, but not particularly for Haringey, but it would be. So if you imagine that your blocks of flats are in this particular area where national electricity network goes down, then that can be quite a serious thing, because it will render many devices unworkable. So you have to think about what would happen if you had a national electricity network blackout. And they present that in the form of a red, orange, green chart. You can go to a more detailed level of presentation and consideration. In this case, the consequences have been divided into 4 different kinds. So obviously the top consequence to consider is the effect on people. Secondly, we've got the asset, which is a building, the environment. So that's an important one, because if you have a serious event in your particular building, it may well affect other buildings or facilities close by. For example, I've been in tall blocks of flats which are right next to schools. And if a tall block of flats starts to have fire problems, for example, that could cause serious environmental problems to your neighbours. And reputation is really about reputation of the people running the building. And then likelihood is how likely is it that this particular kind of event occurs. So you put together the severity, the likely severity, and the likelihood of it occurring. We get, again, a red, yellow, green type of explanation. So back to Bowtie again, just to show you, this is Bowtie using a particular bit of software called Bowtie XP, and there are several other Bowtie solutions which allow you to do this. This allows you to attach to your Bowtie diagram, in a software sense, a lot of other things. For example, the responsible persons or parties for different barriers, critical documents about them, a whole series of things regarding critical equipment, which allow you to form a better idea of the threat likelihood, the barrier effectiveness, and the consequence of severity. And the overall risk is really the combination of those three things: the threat likelihood, barrier effectiveness, and the consequence of severity. So you may want to look at some of these software solutions which allow you to get a good hold on what the risk severity is going to be. Just to mention about HAZOP. HAZOP is a structured way of examining risk management in a system. It's been particularly used in the petrochemical industry, but it does rely really on having what in the petrochemical industry is called process and instrumentation diagram, P&ID, which sets out very clearly on a piece of paper the whole system. That's not so easy for a building. However, the way in which a HAZOP investigation is carried out is really a very good way of carrying out any investigation, in that it has a chairperson, a scribe, and so on, and has a particular way of tackling the problem. So I think that this may well be appropriate for some modern buildings. It will need to be adapted, of course. If you're interested, then the IMechE published a guide called HAZOP Guide to Best Practice by Crawley and Tyler. So I think it's worth thinking about if you have modern buildings. Finally, we come here to safety management system. And safety management system is really a very critical part of the safety case. It's how you keep your whole system going. And it also is how you can achieve a continuous improvement process, which is something that you need to have if you want to improve overall building safety. Do you have one? So here's a diagram to try and illustrate the operational management task, which the safety management system is really there to carry out for you. So on the left-hand side, the two green boxes show inputs, if you like, of tasks. So at the bottom is the important residents' voice requests, which means where a resident said something isn't working, something's wrong, can you do something about it? There should also be some kind of complaints procedure associated with that. At the top of the second green box on the left-hand side, the top is the management of external consultants and contractors for inspection and test. So the safety management system should focus on how often you have, for example, fire risk assessments, fire alarm checks, all those kind of things. And in the middle is a task triage, where all the tasks that come in almost on a daily basis, I would say, have to be looked at. So these are the actions from all these different assessments and surveys, residents' requests, and also government safety notices. For example, there were lots of safety notices on cladding. And these have to be lined up, and you have to assess really where is the priority in this. So some of the, like a fire risk assessment, will probably give you a risk assessment on which tasks are most urgent. So you need to put those into a red, orange, green file and then tackle them accordingly. And then you have to manage your internal and external resources and incoming materials. So you may have internally work teams who can do some of these tasks. You may need to call in external contractors. And then you will have external resource constraints in that you may need to order in materials. You may have some stock of materials and may need to order in extra materials. Finally, at the end, you have the green block there, which shows that all those tasks have been solved, sorted out, and done. And then at the bottom, I've put in the managed continuous improvement, which is a plan, do, check, action, which says, how is this whole process working? It may be useful to think of it as a data flow. So across the top, I put in there, for example, inspection reports, barrier maintenance, which might be regular maintenance of different kinds of barrier, residents' voice, and plan maintenance. So those are the data source which generate various tasks. We then have the resource management to say how can we solve these tasks or action these tasks, the task resolution. At the bottom, I've shown a metric. So there should be really a metric associated with each of these groups of workflow. And those metrics are what will allow you to do a continuous improvement program. So one of the things that Dame Judith Hackett mentioned particularly was learning from other industries. And I think this is a very important thing to do. There is an awful lot of information out there on the internet, of course. I think for residential buildings, we can learn quite a lot from the aviation industry. If you think about an aircraft conveying people from A to B, that's really is a structure full of people, and a residential building is similarly a structure full of people. So there's a lot of commonality between these two situations. And the aviation industry has put out some good stuff on this whole of the safety situation. So here's their outline for best practice safety management systems. So safety policy is the first section. There we have to have management commitment to the whole safety process, safety accountabilities, that means who is accountable, who is the duty holders and so on, the appointment of key safety personnel, coordination of emergency response planning and SMS documentation. And then we have safety risk management, which is hazard identification, which we've mentioned, risk assessment, which we've mentioned, safety assurance, which is safety performance monitoring and measurement, management of change. So for example, this management of change could be change of ownership of the building, it could be a change of the building itself due to refurbishment, it could be a change of regulations affecting the building, and then continuous improvement. And then finally, we have safety promotion, which is also very important, which is training and education. And here we must talk about both the management team and its operators who are looking after the building, and training and education of the residents as well, so they know what's going on and can do their best if something does happen. And finally, safety communication is a very important factor. So we will have another webinar on the safety management system in due course. So finally, we come to the safety case report. So remember, this is about putting an argument or claim, preparing the evidence to show that your building is safe because. So here's some extracts again from the HSE website. See, the safety case report is a document that summarizes your safety case. It identifies your building's major fire and structural threats and hazards, shows how you're managing the risks as far as you can. The report should give the reader confidence that you have identified your building's major fire and structural risks and are managing and controlling them. Safety case report also has to take account of the fact that no system will ever be completely safe. So the goal of the argument is not true, really. And in the UK system, we come across the concept of a LARP, or in the Building Safety Act, all reasonable steps. In other words, you have to show that you've taken all reasonable steps to make sure that the building is safe. In other industries, you will find these other terms being used, LARP and SFAIR, and they really boil down to the same thing. But the Building Safety Act uses the term all reasonable steps. So here are the list of these different webinars which will come out in due course. So today we have number 1, which is the introduction. Number 2 is gathering information, golden thread. Number 3, structural condition assessment. Fire engineering. Number 5, smoke control. Number 6, hazard identification. Number 7, bow tie modeling. Number 8, root cause analysis. Number 9, risk assessment. Number 10, safety management systems. Number 11, testing, commissioning and life cycle. And finally, number 12, safety case report preparation. So hopefully I've touched on these topics today and introduced you to the idea. And as these different webinars come out, the links to them will be available on the IMechE and other websites of the different institutions involved. The websites don't directly necessarily fit to the safety case report process we've proposed, but they are supporting data and information that will help you, we hope, to do this process well. So links will be available in due course. If you go to the IMechE one where you are today, you should find that in due course. So thank you very much for listening. My own email, if you want to have it, is cox3546@gmail.com. I'll try and answer you as soon as possible if you don't manage to get your question in today. Thank you very much. So over to you, David.
Hello, everybody. Back again. I hope you can see me all right. That's better. Thank you, Brian.
Okay. Try and get my picture back now.
We've got multiple screens here open, so I hope people can hear me. Sorry about that. So that was an interesting presentation by Brian, and hopefully sets the scene for this series of 12 webinars. The next scheduled webinar is due to be by Connor Logan of Colt International on smoke control. I believe that's to be in May. It will be publicised on the IMechE website. So if you follow the link that you have now, it should take you onto the website and you should be able to see that. I'm not exactly sure how many people we've had attending today. We'll get that after the event, and hopefully this from Brian will create an increasing interest along the way. What I've been asked to say to you is that please publicise this series of webinars. If you can have people that are interested, that you know, have them come onto the IMechE website. They'll be able to register, and they will be able to be sent the link to the webinar from today. And if they don't see the other ones live streaming, they will be able to get the links to those and watch them at their own leisure. I'm looking at the attendee questions. So far, we don't have any questions. So I would just draw your attention to Brian's email address and email him any questions that you may subsequently have. Probably nearly not much more than I can say. Or add to what's been said already today. So on that note, it's probably appropriate that we leave you now. Wish you a good rest of the day, and hope to pick up with you with smoke control and Connor Logan in the near future. Thank you.